All right, so we want to solve this 3 by 3 systems of equations using Gaussian elimination. First thing we should do is, of course, put this in the augmented matrix. Now, you have to be careful with these, right? These are missing some variables, so make sure you put zeros in their place. Okay, so we got 1x, 1y, negative 3z here. We'll put the vertical line and the negative 1 there on the other side. Remember, the second equation is missing an x variable, right? So put a 0 in its place. 1y, negative 1z equals 0 on the other side. Negative 1x plus 2y. There's no z here, so put a 0 in that spot and put the 1 here, right? So this is our correct augmented matrix. So we already have a 1 in the first row, first column, which is good, right? So we want zeros below it. The second row already has a 0, which is good. So we just need to get a 0 in this location, right? So this turns out pretty good, right? We'll just add row 1 with row 3, okay? So by doing so, if we add row 1 to row 3, remember row 1 is not going to change. Okay. Row 2 is also does not need to change. Okay, but we're going to multiply, or we're just going to add row 1 and row 3 together, right? 1 plus negative 1 gives us 0. 1 plus 2 gives us 3. Negative 3 plus 0 just gives us negative 3. And negative 1 plus 1 gives us 0. Okay. So this is good, right? We got zeros. We got a 1 in the first entry in the main diagonal here and zeros below it. You notice this entry is also a 1, which is good, right? So now we just want to get a 0 below it. Okay. So we see the 1 here, which we're going to use. We see the 3 here underneath it. So we're going to multiply row 2 by negative 3 and add that to row 3. Okay. We're going to multiply the second row by negative 3 and add it to the third row here. Okay. What happens then, right? Well, first row does not change. I guess I should put that vertical column there, right? Second row, remember, does not change, but we are going to use row operations on it, right? So we're going to multiply row 2 by negative 3 and add it to row 3 here, okay? We get a 0 here. Here we get a 0. And then we also get a 0 for this last entry. Okay, well, what does this mean, though? You notice, wait a minute, the row is all zeros, right? Well, remember, these are the coefficients. This is the equal sign, so this means that 0x plus 0y plus 0z is equal to 0. Well, if you think about it, no matter what we pick for x, y, and z, this will always be true, right? So what does that mean? It means that this system of equations has infinitely many solutions, okay? Now, depending on what you use, there's a specific way to write this, okay? But notice what the first equation says, right? The first equation says that x plus y minus 3z is equal to negative 1. The second row says that y minus z is equal to 0. Okay? So what we can conclude that y is equal to z, right? So as long as y is equal to z, and then x, let's isolate the x now, right? We'll get the x by itself. So x is negative y plus 3z plus 1, right? Okay. So this system of equations is based on this solution right here. Okay, so essentially, once we get the row of zeros, we know that there's infinitely many solutions. Okay? And then we just sort of look at the other two equations and solve for those variables. Okay, so we should get some idea, okay, of how x, y, and z are related to each other to give us these infinitely many solutions.